All right, we are on lesson 7-7. Today's date is Friday, April 12th, 2019. I can't write 12. There we go. 2019. All right, this is our last lesson of the unit, and it is kind of a cool lesson because it relates Algebra 1 to Algebra 2. Algebra 1, we always learn about linear functions, a line. How do we graph a line, standard form, slope-intercept form, all that stuff. Now we are finally comparing it to exponentials, which technically can be taught in Algebra 1, but they were taught for our school in Algebra 2. So connecting Algebra 1, Algebra 2, linear versus exponential. Fight! So the equations. This is the general form for a linear equation. I have a plus bt, exponentials a times b to the power of t.
Where?
On the back.
Can I just take this?
Oh,
I don't
yeah.
have one.
Yes.
Am I supposed to have one of these, right?
You're supposed to have one, yes.
Just one.
Well,
What's
you
that
have
one?
one of them. That's
From
today.
today?
That's yesterday. Or
The
that's
one
2
that-
days ago. Quiz was yesterday.
Oh, okay.
All right, so let's go ahead and label these things. A, this is the start. Just like this A is also the start.
Hold on. Sorry, I'm sorry.
That's why I was pointing the pencils back there.
Oh, I'm sorry. Would I just break your thing right here? Why do you have two?
I'm testing to see why they're not coming out.
Okay.
All right, we know that in the exponential form, this B has a very special name. What do we call this capital B? And I forgot to pass out cards, but a quiet raised hand. What do we call that capital B? What do we call it? Who has it? What is that capital B? Eva. It is the common ratio. Call it the common ratio. Thank you, Eva. And if I come back here, oop, that's not the right one. If I come back here, Eva, there is your XB. All right, so this B over here is also some other common thing. It's what common, it's not a ratio. So ratio is when I divide things. Good guess though, Gio. Anyone else want to take a guess? Is it called the common difference? And that's all I want to say about equations. We'll come back to equations in a sec, but let's move on to tables for now. So I have a linear table versus an exponential table. How do I tell one from the other? That's the majority of the homework tonight. Half of the homework is just, can you tell the difference between a linear versus an exponential table? So the first thing that you need to check is, are you increasing by a constant amount over here on the left-hand side? And you can say yes, you nod your heads, yes, you're adding 2, adding 2, adding 2. Same thing kind of happens for the exponential. Are you adding a constant amount? Adding 3, adding 3, adding 3. You need to be increasing by a constant amount for the x for both exponential and linear. It's the same thing. Chris, come on, man. Okay. So from there, I need to figure out what's happening on the right-hand side. Of course, if I want to find the start value is going to be something special. We'll talk about that down here. But what's happening in terms of going here on the right-hand side? It's adding 7 each time. Add 7, add 7, add 7. Another way to figure out that it's adding 7 is, and this seems like it's straightforward, but it will start confusing us, is I can do one value minus the previous value, 24 minus 17. So I'm really subtracting. That's why I get a difference. It's called the common difference, is because I do the second value minus the first value. I could have done 10 minus 3. I could have done 17 minus 10. I'm subtracting in order to find what that common difference is. So you always want to be thinking this 7 is really the second minus the first, or the third minus the fourth, or the fifth minus the fourth. It's a difference. It's a subtraction problem. It's different when I'm talking about an exponential. And this one is going to be not as straightforward. What am I doing to get from here to here? From here to here, from here to here. What operation? I don't care about the numbers at all. I care about add, subtract, multiply, divide, powers, square roots, all that stuff. What am I doing to get from 5 to 13.5? What am I doing for an exponential? Quiet raised hand. Who wants to take a guess? You have like a 1 in 6 chance. Gio. Yes, you have it right. It's multiply. Thank you, Gio. You should be multiplying because it's an exponential function. So this is times something, times something, times something. It's timesing by the common ratio, multiplying by the common ratio. So how do I find the common ratio? Very similar for how we found the linear common difference. I have to do this opposite function. So if I was adding 7 here, I'm going to do the opposite of times. I'm going to divide. I'm going to divide this 13.5 divided by 5. Or I could have done 98 divided by 36.5. Or I could have done 36.5 divided by 13.5. All of those are ratios. For this example, I'm going to say 13.5 divided by 5. I'm doing the second divided by the second divided by the first. And if I do that, 13.5 divided by 5, I'll find that my common ratio, in this case, was 2.7. So each of these common ratios was multiplying by 2.7. You can check that. So 36.5 times 2.7 should be about 98. Let's check it out. 36.5 times 2.7, is it about 98? It is. It's 98.5, rounding up. Or rounding down, I guess, to get to 98. You are approximately multiplying by 2.7. So this is the important information. It's linear if what gives the same answers. I'm looking for an operation here. Addition, subtraction, division, multiplication, something. What operation means it's linear? Careful here. Subtracting. Subtracting the second from the first. I mean, yes, you are technically adding one to the next. You could be subtracting one from the next. But if I do this thing minus this thing, the second minus the first, that's the thing I care about. That's why we call it a difference. It's because I'm subtracting. So please write in here subtracting. And I wasn't very complete with this line. I should say subtracting the second from the first or the third from the second, but subtracting in general. Who got subtracting? Was it Andrea? All right, thank you. All right, and then it's exponential if doing what gives roughly the same answers. Quiet raised hand. You can say 2 words here and it should be the same. Eva? Dividing. Yeah, you could say dividing or you could say ratio. Thank you, Eva. All right, so that's how to tell one from the other. You always subtract and see if you get the same answer, or divide and see if you get the same answer. You have to check 2. So I have to do like 24 minus 17 and maybe compare that to 10 minus 3. Or I could do 24 minus 17, compare that to 17 minus 10. They should always be the same answer subtracting, or they should always be the same answer dividing. I'll show you an example problem eventually, but for now, let's just go on to finding equations. So the second half of the homework tonight, all in one homework assignment, is finding the equation from a table. It'll give us a table and say, which of these equations approximates that table? All right, how do I find the value of A? I'm looking back up here. This value of A, it's the start value. That start value for this linear function is what? What is the start value? Is it 3? Is it 10? Is it 17? Is it 24? What is the start value for that table? Quiet raised hand. What is the start value? Geo?
3.
It is 3. This start value, A, is 3 because this is where the y value, or this is the y value. See, it's a value of y. Where x is equal to what, Geo? 0. Wherever you have 0, that's going to be your start value. So thank you. There is more advanced stuff that I can talk about once we hit pre-calculus next year. But for now, that's as simple as a definition as we can get. All right, this next part is going to be the trickiest part of today's entire lesson. I guess this part is tricky and this part is tricky. But for now, this is the first half of the tricky part. Why did I put 2b instead of b? Normally b should be the common difference, but why am I writing 2b? What do you notice about the linear function that has a 2 in it? Why did I write 2b instead of just b? What else has a 2? In this table, do I see a 2 repeated anywhere?
Because you're adding 2.
Adding 2 where? To the x's or the y's? Exactly, yeah. Because I'm going up by a constant amount of 2, I have to say 2b. If I was going up by a constant amount of 3, I would be saying 3b. Whatever the constant amount is on the left, that's what I start with. 2b in this case. So can we make a note of that? This is increasing X amount. X is increasing by 2. So 2b is equal to, okay, it's called a common difference. I'm using subtraction for a difference. Which two numbers do we want to do? I could do 24 and 17. I could do 17 and 10. I could do 10 and 3. Quiet raised hand. Who's going to help us set this up? I see only one hand. I just gave us 3 choices. Just have to rattle off one of those choices. Not a single person aside from Gio. Okay, Gio, go for it.
10, 7.
All right, 10 minus 7. What is 10 minus 7? Or
10 minus 7.
10 minus 3, and 10 minus 3 is 7. Therefore, 2b is equal to 7, which means Gio, b is equal to, divide both sides by.
Wait, what?
So right now I have this equation, 2b is equal to 7, right? How do I solve for b? I want b by itself. So 2b is equal to 7, divide by 2, and I get 3.5. Thank you, Gio. This common difference, this b, is 3.5. This changes a little bit when I talk about an exponential function. All right, what is my start value for my exponential function? What is a? Fiona. It is indeed 5. And why? That's where x is 0. It's the y value where x is 0. Thank you, Fiona. It's the same thing for a linear function, so it's pretty easy. It's the same thing. This next part is going to be a little bit different. Instead of writing 3b out front, because I'm increasing by 3 on my table, instead of saying 3b, I say b to the power of 3, because I've multiplied by b 3 times instead of adding by b 2 times. So if I multiply by b 3 times, I get b to the power of 3, and I set this equal to the common ratio, which means I'm dividing. I get to choose 2 numbers to divide. Someone help me out. Which 2 numbers should I divide? Andrea.
13.5.
Yep, that is one of the 3 options you could have done. 13.5 divided by 5. And I'm going to do that for us. 13.5 divided by 5, and I get exactly 2.7. 2.7. Thank you, Andrea. This next part is a little bit tricky, so it is going to require a different volunteer. Right now, we have this equation, b cubed is equal to 2.7. I just kind of cut out this middle part. How do I get b by itself? James? Multiply by what? Ooh, you're close, but that would just get b cubed. I want to get b by itself, so I have to undo this 3 somehow. That's a good guess. You think you got it still? Pass it to who? Okay. You have to take the cube root, yeah. So the cube root is the equivalent of taking both sides to the power of 1/3. So I'm going to solve it 2 ways. I'm going to solve it Fiona's way, which she said to take the cube root of both sides, which is correct. So I'm going to take the cube root of the left and the cube root of the right. That's taking the cube root of both sides. The cube root and cube will cancel each other out. This cube root and cube will cancel each other out, and I'm left with b is equal to the cube root of 2.7. I'll find what that is in a sec, but I want to show you the second way of solving this. The second way of solving is saying, oh, well, I can take this to the power of something. If I multiply 3 by what gives 1? 3 times what is 1? Say it louder, Andrea.
1/3.
1/3. I can take both sides to the power of 1/3. Thank you, Andrea. If I take both sides to the power of 1/3, the 3 and 1/3 cancel out to just 1. I'm left with b. I come back here, change it to green. That leaves me with b again. b is equal to 2.7 to the power of 1/3, which is the same thing as the cube root of 2.7. Coming here on my calculator, 2.7 to the power of, start my parentheses, 1 divided by 3, and I get about 1.39. Just going to round, 1.39. And that's the same answer here and here. 1.39, 1.39, which means my common ratio is 1.39. All right, that is the basic work that we're going to be doing today over and over again on the examples on the back. I have 2 examples. Let's flip over to the back. And as we're flipping over the back, this is a good check-in point. How well are you following the lesson? Are you okay? Were you not really following because of whatever reason? Gio's giving me a 1 thumbs up.
Sorry.
4. Chris, how are you? 3, okay. Yeah. Let's go to example 1. I have a table. I need to first determine is this linear or exponential, and then choose the correct equation. All right. Is it linear or exponential? I hear one person say linear. Fiona, what are you going to say, Fiona? Exponential. Who else? Let's do linear is 1, exponential is 2. Vote now. Linear 1, exponential 2.
4.
Now Gio's doing 4. Fiona, talk to me. Why did you say exponential and not linear?
You can't add something that's like the same.
Okay, so you're saying if I do 44 minus 44.9 minus 34, that should be the same difference to get to the next value, and that can't happen, something like that. So 44.9 minus 34. You're allowed to use calculators for all of Khan Academy. So if I was adding, it would have been adding 10.9. Let's see if I add 10.9 again. 44.9. If I add 10.9 plus 10.9, I should get 59.2, but I don't. I get 55.8. So that clearly doesn't work. It broke adding, so it's not adding. Let's try multiplying by something. To multiply by something, I have to divide. So I'm going to do 44.9 divided by 34. 44.9 divided by 34, and I get about 1.32. 1.32. That means if I multiply 1.32 times 44.9, I should be able to get to 59.2. Let's see if that works. 44.9 times times 44.9, and
Whoa, what are you doing?
1.32, sorry. And I do get about 59.2. So that does work, and it should work for all of them, and it does. So I do keep multiplying by 1.32 times 1.32 times 1.32. And you can check each of these fractions. For example, if I do 103.2 divided by 78.2, I should get about 1.32. Let's check it out. Let's move you out of the way. 103.2 divided by 78.2, and I get about 1.32. All of these have the same common ratio. I can do any of these divided by any of the others. All right, so it's not linear. Which two choices, I need a quiet raised hand for this one, which two choices can I eliminate? Just knowing that it's not linear. I only see one hand. 2 hands. Stego. A and B. Yeah, A and B were our linear choices. Those both, oh. Oops. I made a mistake. These should have a multiplication sign here. Let me just give you guys all the teacher error for that one. You all got 70. All right. That should be a multiplication sign. Sorry about that. It is to the power of t. These are exponential. Now, which one is it? Is it 1.32 or 1.15? Ooh, Gio's saying 1.15. Gio, why did you say that? Just trust. 1.15 is correct. Someone explain why.
Because Gio said it. Yeah.
Gio is the master of all knowledge. I trust him with my life. Here's the reason. I'm going up by a factor of 2 on the left, plus 2, which means I have my common ratio b to the power of 2 is set equal to 1.32, which means I need to take both sides to the power of 1/2. Both sides to the power of 1/2. So 1.32 to the power of 0.5 is 1.15, rounding. 1.15, that is the reason why it's D. Thank you, Gio, master of all knowledge. We are on to example number 2.
Wait, can you go back?
Wait, what? How did you get D?
I got D because b to the power of 2, since I'm adding 2 each time, b to the power of 2, and then to solve, I take both sides to the power of 1/2. 1.32 to the power of 1/2, 1.32 to the power of 1/2 is equal to 1.15, roughly.
Can you say that again in English, please? I'm just kidding.
Okay.
When you go back up, that was.
We're finishing copying this down. I still see pencils writing. Pencils are moving. Chris, can you take off your hood for me, please? And we are on to example number 2. Go ahead and look at example number 2. You have to first decide, is it linear or is it exponential? And be ready to explain why.
Wait, what was the first one?
First one was exponential.
This one's linear. Okay.
I probably put two of the same type to trick you guys.
I can't do that. It has to be.
All right. So interesting logic, but I do want you to have the mathematical reasoning, not the philosophical or what is it, the psychological reason. Psychology, Mr. Sindel will try to do one of each. I try, but sometimes I try to trick you too. All right. One finger if you think it's linear, two for exponential.
Give me 1 second.
It does go up pretty fast. Exponentials go really, really fast.
Wait, give me like 5 or like 10 seconds.
One for linear, two for exponential. One for linear, two for exponential. One for linear, two for exponential.
I don't know.
Don't know. You can do fists for you don't know. All right, let's check it out. Okay, let's assume that it's linear and see if it breaks that rule. If it's linear, then I should be adding the same number, approximately. Again, modeling isn't quite perfect, but it should be pretty darn close. So 63.3 minus 7, 56.3. So I should be adding 56.3. Let's add 56.3 and see what happens. 63.3 plus 56.3, and I get 119.6, which is not really working. But it was close. Let's see what happens if I'm multiplying. If it's what's up? Can you wait until after the lesson? I'm almost done. If I'm multiplying, that means I'm doing 63.3 divided by 7, which means I'm multiplying by about 9.04. So I'm either doing this or I'm multiplying by 9.04. Let's do 63.3 times 9.04. 63.03 times 9.04, and I get,
Why is it
oh,
0.03?
Yeah.
wait, what?
Why is it 0.03 and not 0.3?
You did 63.
Oh wait,
You
shoot.
said 63.0.
Oh, did I?
Yeah.
That was my bad. 63.3 minus
Yeah, I know.
7.
Minus. Oh wait, okay, hold on. None of them work, so I don't know what's.
You have to choose one,
You know
though.
what it is?
Which one's closer?
Which one is closer? So if I do 63.3 times 9, that is crazy off. That is so far off, it cannot.
Wait,
It cannot
nine.
be this
Where
one.
you got 9 from? Oh.
So it is linear, right?
It actually is linear.
Yeah, that's right. You guys are
Check
wrong.
this out. Let's see what happens. Let's try this one. 120 minus 63.3. 120.1 minus 63.3. By the way, Khan Academy is also off by a little bit. This is 56.8. So this one was adding 56.8, which is still pretty close to the other 56. Let's try 176.8 minus 120.1. 176.8 minus 120.1. That's 56.7 plus 56.7. They're all pretty darn close. It was actually linear. Khan Academy loves doing this where they're really close to each other, but not quite the same number.
Alright.
I don't like that.
So it's not, and again, I forgot to do the times. These should have been times, but it can't be D and it can't be C because those are exponential. So which one is it? Is it A or B? 1 for A, 2 for B. Is it A or B?
A.
It's not A.
Add my answer anymore.
It's not A.
Why is it B?
So the answer is never
Because,
gonna be the
again,
same
you
as-
always have to look at how much you're going up here on the left-hand side.
11.3.
I'm about to explain it, Chris. On the left-hand side, I'm adding 5, a constant 5. That means 5b is equal to this ratio of, I'm going to set it to 56.7. If I divide both sides by 5 to solve for b, that means 56.7 divided by 5 is about 11.3. And I get the correct answer as B. Ask me questions. Write your summaries in. All right, that concludes the lesson.